Next I have to repeat all the steps I did in Mongo, but this time using the Postgres. So the first thing I did was to create a database. So we just used create database and then the name of the database. And to go inside the database, you just use \c. So I started by creating a movies table, and for the actors field, I used an array, a text array, to store all the names of the actors. I could have made that into a separate array, but I chose to just put it as an array. So the result of this, you can see it's telling me that it has created the table. So here to insert into the movies table that we just created, here I'm specifying each of the columns I want to put it in for. If I didn't want to specify which columns, I just, for example in this one, I'm not putting anything into franchise or synopsis, so I just use empty strings, but here I'm just specifying it. Now to see the results of this, so each time I inserted something, I can see that it has been successful by this insert. So these are all the inserts. Next, to query the tables, so to query the table movies to get all the rows, it's just select star from movies. So here it's gonna show me it's gonna return all the rows. So to get all the rows where the writer is set to Quentin Tarantino, this is just select star from movies, just as before. But this time we're using the where clause to specify that every time the writer is set to Quentin Tarantino. So you can see from my result here that I'm getting 2 rows back, and this is where the writer is equal to this. Next part is to search through the movies table to find a particular actor, in this case Brad Pitt. So as this is an array, I couldn't just use the where clause by itself. You have to look through all the values in the array for that specific actor. So this is why I used any actors. And from the result you can see that every time in the actors, when it's equal to Brad Pitt, I get this result. So 2 rows back. To get the rows where the franchise is set to the Hobbit, this is exactly the same as before, but this time we're just changing the column to franchise, and you're looking for the Hobbit. So here you can see every time the title is equal to Hobbit, so it's giving me 3 results back. Next, query to get all the movies released in the 90s. So here I'm using select star for movies where the year is between. So between will give you a range from 1990 and 1999. So here it's giving back 2 years, 1999 and 1994. And so they are between this range. Next query is to get all the movies released before the year 2000 or after the year 2010. Or you can see the OR is the same as Mongo, but this time instead of GT greater than or LT less than, in Mongo we're using actual symbols for this. As this is OR, even if one of these statements is true, I will get the results. So from the results you can see the year is equal to 1999, 1994, 2012, 2013, and 2012. So therefore this is less than 2000 and the year is greater than 2010. So the next section is all about updating the tables. So the first thing I had to do was add a synopsis to the Hobbit, an unexpected journey, and this is what I should put in for that column. So basically I just used update movie set synopsis is equal to whatever we were told to, where the title is equal to the Hobbit and unexpected journey. This is basically going to look for movies with this title and find the synopsis column and put this information inside. Here for my result, this is the query I used for the update, and it's telling me that it has successfully updated one. And to actually see if this is true, I used select synopsis from movies where title is equal to The Hobbit Unexpected Journey, and you can see that I do get the result back. So the next query is exactly the same, but this time it's for the Desolation of Smaug. So it's going to look for the title in the movies table where it's Desolation of Smaug, and set the synopsis to this information. And just as before, for my update, it's telling me that it's successful, and just to see that it actually worked, just to double check, I did select synopsis for movies where title is equal to The Hobbit and the Desolation of Smaug, and it does return the information I put in. So the third part is a little bit different. This time we have to update the actors array and add a new name, Samuel L. Jackson. So I did update movie set actors is equal to array append the actors array and this name. So this is basically going to put this name into the array of actors, and that's why I used array append. Similar to Mongo, if I was just to use set actors is equal to this name, it would just overwrite all of the names that are already there, so I don't want to do that. So here's my result. This is telling me that the update was successful, and when I queried, I could see that the array has been updated and there's 3 names now instead of 2. Next section is text search. So the first query, to find all the movies that have synopses that contain the word Bilbo. So this is just select star for movies where synopses like Bilbo, percentage, Bilbo, percentage. If percentage was at the beginning, so if it was only at the beginning, it would look for every time this comes at the end, so Bilbo will be at the end. If the percentage was at the end only, it would look for words that begin, sentences that begin with Bilbo, but because it has percentage on both sides, this can be anywhere in the middle or at the end or at the beginning, it doesn't really matter. Now you can see that I get 3 results back for the synopsis, so Bilbo, Bilbo, and Bilbo. Next part is exactly the same, but this time we're looking for Gandalf instead of Bilbo. So here you can see from our result, it does contain. Next part is to find all the movies with the synopsis that contain the word Bilbo, but they shouldn't contain the word Gandalf. So both of these conditions have to be true, so it should contain Bilbo and it should not contain Gandalf. And I basically just makes it case insensitive. And the result of this query is it's giving me back all the synopses that do contain Bilbo but not Gandalf. So the next part is exactly the same. It's looking for 2 words, but this time it's or. So both of these conditions don't have to be true for the output of the results. So if it contains dwarves or Hobbit, I should get all the results. So the output of this, you can see the first one contains Hobbit and the second one that's returned contains dwarves. The next query is the same as the ones before, but this time we are looking for a synopsis that contains both the words gold and also dragon. And then the output of this, we're getting 1 result back, so this is telling me that there's only 1 synopsis that contains both the word gold and also the word dragon. So the next part is to delete from the movies. So delete from the movies where the title is equal to this. So you can see that it's telling me that it has deleted. Same as before, to delete the avatar, we just changed the title to avatar, and again, it's telling me it's successfully deleted. So the next section on relationships, I had to make 3 tables, so users, posts, and comments. For the users table, I used serial primary key, so this is auto increment. It's going to automatically increment. And then username, first name, last name, text. To insert into users, I'm going to specify the columns I want to insert into, and then the values I want to put into these columns. And here, as you can see, I've created the table with the column names, and then each time I've inserted, I've just select star from users to see it has inserted. Next table was the post table, and again for the post ID I'm using serial primary key. It's going to auto increment, and I'm selecting the columns I want to put my information into. And again, you can see this table has been created with following column names, and then each time I insert it, just select star to see. Next, I created the table comments, and then I used the serial primary key in for the comments ID. I also referenced the post ID as the foreign key from the posts table. So like where the post ID is the ID of the posts, borrow something. So if I go back, I can see that borrow something has the post ID of 4. So to insert into this table, I'm going to do username, post ID, comment. So the username is Good Guy Greg. The post ID, as I just showed you, is 4, and then the comment is this one here. Hope you have a good deal. And this is the result, so this is me making the table for the column names. And then I basically use the same method to put all of these values inside. And it's inserted them. Next section is querying the table, so to find all the users, it's just select star from users. So it's telling me there's 2 users, Good Guy Greg and Scumbag Steve. Next is to find all the posts, so select star from posts, and it's going to give me all the posts. Next 2 queries are about getting posts that were authorized by Good Guy Greg in the first one and Scumbag Steve in the second one. So when I did this query, I get the ones that Good Guy Greg posted and the ones that Scumbag Steve posted. Next one is to find all the comments, so it's just select star from comments and it gives this back to me. And then next 2 queries are about comments that were authored by Good Guy Greg or Scumbag Steve. So this is similar to the ones before, but you get the results like this. So the last query is to find all the comments belonging to the post reports a bug in your code. So for this, I made aliases. So for the comments, it's com, and for the posts, it's post. So I did select star from comments, post, where the comments, or the post ID in the comments is equal to the post ID in the posts, and the post title is this. And the result, this is the result I get. So the username is Scumbag Steve, and the title is reports a bug in your code. So now for some differences between Postgres and MongoDB. So Postgres, it's good for data that's similar and that fits into a really good structured schema. It's Postgres also includes powerful schema constraint tools. But if your requirements are too flexible to fit into a schema and you don't need to write or read like large volumes of data, then you should be considering Mongo instead. So Mongo is very flexible, it's very easy to use, and it can do big or small jobs. It enforces no schema, so this is what makes it different to Postgres. You can have optional, like, it can contain fields that no other document in the collection contains. So this is different again from Postgres, where the data is similar. And the last thing is, it's very easy to make collections and insert data, and it saves time.